All right, now, what do I do after I get it in terms of one variable? Well, the reason why I got it in terms of one variable is so I can differentiate, right? Now, let's be careful, right? Based on whatever letters you pick, okay? I'm differentiating this guy. This is a function I'm differentiating, right? So dn, and I'm differentiating with respect to, we're used to seeing x's over here, right? But it doesn't matter, it's just a label, okay? So this is dn on dy, differentiating this whole thing with respect to y. Okay, this is a nice easy function. What's the derivative? Yep, minus 16. And the constant just vanishes, okay? So, great. I've differentiated. What was the point of getting the derivative? Okay, so I want to make this equal to 0 so I can find possible turning points, right? Now, by the way, please don't skip the next line, namely this one, i.e. Okay, don't skip that, even though, you know, the arithmetic's really, really simple. Because this shows that you understand what this is about, okay? So therefore, from here, you can say y is 4, okay? All right, what do I do with this? This is a value where I'm going to get the turning point, hopefully. Where do I go next? Yeah. Okay, so I could take y equals 4, and I could slap it into, I think you meant, oh yeah, okay, I could slap it into here. That'll give me a value for x, right? And then, what is the smallest possible value for n? I can pop it into here, and then I'll get my answer, which was 32, okay? But I need to do a little bit of work before I actually substitute in, right? I've got to prove that this is where the smallest possible value comes from, right? Which is where all of this business starts coming in, okay? So what should be my next step? For starters, it's a turning point. Well, we think it's a turning point. How do we know if it's a turning point? Okay, I got a couple of options here. I got 3 options if you include graphing. It looks a bit excessive to me. I could use the first derivative, or I could use the second derivative. Okay, I could test this guy on either side of the stationary point. So I could test 3 and 5. Or I could use the second derivative. Which do you guys reckon we should go for? Second derivative, because it's super easy to differentiate, right? So here's the second derivative. Equals 4, right? I probably should have popped in the middle here, determine nature. So it's clear why I'm doing the next derivative, okay? Now, it's a constant, right? That means every single stationary point that I find, of which there's only one, they should all be concave up, right? This is positive, concave up. And concave up means it's a relative minimum, right? Now don't skip. I can't say it is the minimum yet.
Well, you know how it's relative?
I said it was a minimum, so I'm not wrong.
As opposed to what? Okay, because relative means, you know, you can have as many relative minimums as you like.
Yeah,
right?
but what if
So-
there is only one minimum?
Then I'm going to go to the next bit. Yeah, you start, it's sort of like innocent until proven guilty, right? So I know it's a minimum of some kind, but I just don't have enough evidence to show that it's the minimum. Does that make sense?
Can we just say it's the early one?
Sorry?
Can we just say it's the early one?
No, not enough.
Can
Because
we-
I'm going to have to get into endpoints in a second.
Alright.
Wait, could it be relative and then turn into absolute?
Could it be relative and then turn into
As you
absolute?
work, improve it.
Hold on, say that again.
Everything's relative.
That's the whole point, Richard.
Yeah, that's
the
right.
whole point.
Everything's relative.
So something cannot be relative and absolute contemporaneously.
What?
At the same time.
Yes, it can. Yes, it can. What does relative mean?
Relative,
Relative means, in this context, right? Stay with me, he's got a point. Relative means with respect to, like, what's nearby. Okay? So it means minimum relative to what's in the neighborhood. Okay? Namely, like these few points either side of it. Okay? The relative minimum is also, well, in this case, let's, there you go. That's right. Ta-da! It's relative minimum, as in the neighborhood, it's the minimum, right? But it's also the absolute minimum because there's no other value that's lower than it because I fixed up my graph. Okay? So yes, relative
So something can be
and
relative
absolute.
and absolute at the same time.
Because we're using the word relative and absolute in very specific ways.
But you know in the test paper when they ask you to figure out if it's relative and absolute, if it's relative and absolute,
No, but all turning points are
Being
relative.
absolute.
It's always going to be relative something, right? That's shown by the fact that it's a turning point, that it turns.
All turning points are relative.
Yeah.
So if it's absolute, it's also
Some of them can be
Yes.
absolute.
All right.